Alright, welcome to part 3 of solving the system of equations through first sending it to an upper triangular form and then solving using back substitution. Now we need to create a user-defined function that accepts a matrix in upper triangular form and uses back substitution and outputs back a solved system of equations. So let's create a new function that will accept a give me 1 second, guys. It's going to accept a final answer, or not accept, it's going to output a final answer. We're going to name this function backsub, and it's going to accept my upper triangular matrix. Again, we're going to take the size of the upper triangular matrix. So here we get row col equal to size of upper. Now we're going to create a square matrix that goes from the first element diagonally all the way down to where it can't go anymore. This is essentially just leaving out that last column of the matrix. We're going to call it check values, and we're going to use the upper matrix going from all rows from the first column all the way to the last, the column before the last. There we go. Similarly, we're gonna create a matrix that is only that last column of numbers. So we're gonna call it our answer value. Values of this upper matrix of all rows, last column. Now what we want to do is create an empty matrix full of zeros so that we can save our answers. We could save our coefficients, or we could save the value of each variable. That's what that's going to be saved in, and there are, in this case, 3 of them. Why, you ask? Let me just write this in. Final answer. Final answer is zeros of column. Zeros, 1, 2, the number of rows. And what that's doing is creating a row vector. Here, 1 row of length row, and row is because you have it's a square matrix, so really you could use column, but you're gonna have 1, 2, 3 answers, and that's the reason we make that matrix that size, not matrix, vector. And now we're gonna solve for this this z value. Remember that how I was calling this x, y, z. We're going to solve for the z value. We know that 7 times z equals 5. So, easily, we're just saying final answer of row. Because it's the last one, we want the last value, which is our z value. So it's going to be saved in the last what do you call it, element of this vector. And we're going to do our answer values of row 1 divided by our check values, check underscore values of row. Again, because it's a square matrix, you can use whatever you want. Any one of these. So now that we know our z now, given this line, we know our z. Now what do we need to do to it is essentially do that. Since we know our z, we can give it to all of these. We can multiply our z by this element and this element, and then we will do the same process. Essentially is divide this guy, and then not divide. Once multiplied by our z, we can add or subtract to here, and then divide our y value to give us our y. Multiply that y to the number here. Add our values for y and z to our answer. Divide our coefficient here, and we will have all three values of our problem. So what we're going to say is for x equal to row, number of rows, that's the number of iterations, or that's where the iteration will start, is 1 under the max number of rows, because you already found the last number. And we're going to go backwards. We're going to go upwards towards the beginning. There. And we're going to say our final answer of our x, because we're counting down and those values are going to get saved in that vector, is equal to answer values of x minus check values here, minus check values of x row multiply by all of the values in this. And here, when we multiply by our value, for here, this will be saved as a 0. So nothing will really happen to this number. It'll only get affected after these guys are added to, after this is added to this side. It will only be affected by the division of itself to here. So here we say our final answer of row divided by check should do it for our back sub function. We come back here and we call our, or we send our upper triangular form to our call function. To our back sub function. We say final. We call the final answer equal to back sub upper. And it's saved in a matrix, in a vector, in a row vector. So we can just let's call the same matrix, and we'll look at our final answer. And there are our values. Those are the correct values for x, y, and z. Now all that's left to do is just to output them using a for loop. We say for x equal to 1 to the length of final answers. We print f our x equals our number 0.0. We close that and we assign our x to the first one, and we assign our final answer of x to the second one, and we close the last parentheses. And this, and we enter our code, or our test case. Oh, well, it rounded here. We could say 2. And there we go. That's our upper triangular form solution to Project 2, Problem 1. Thanks for listening, and tune back again for Problem 2.